Exploratory data analysis, simply referred to as EDA, is typically a part of every other machine learning project or data science project that involves tabular data sets. In this one, we will try to understand how to approach EDA for pretty much every other machine learning project by going through 5 different examples from simple to slightly more complex ones. Now, first, before we go into all of those things, let's first understand what is EDA, what is the high-level purposes of EDA, and what we will try to achieve by doing this. And in the first place, why do we even need to do EDA when starting any machine learning project? All right, let's get into it. Now, EDA is the step where you will get to understand the data in more detail. So first step in typically every machine learning project is to assemble your data, source your data from various different data sources, put it together and form a nice master data frame on which you will be building and training your machine learning models. Now, after you put together your data, you will start to understand the data in more detail by doing very simple things like calculating frequency counts, visualizing the distributions, creating scatter plots and various different types of plots, and understanding the variables in the high level. Now, the main idea is to study the relationships between the variables using various visualizations. I will show you later on in this video, at the end of this video, I'll show you an excellent resource which you can consult for a whole lot of different types of visualizations for data analysis. We'll come back to that. But first, why do EDA? What is the purpose of doing EDA? First is to summarize the data. Whatever data you have, you want to know how many records it has, how many missing values it has. You can use the df.describe function. Any data frame has a function called df.describe. If you simply call this function, you will get to know the mean, median, the various different quantities, all these things, and getting to know the number of unique values, all these things, right? First step is to summarize the data. After you do that, we want to understand which of the existing, so you have a data frame. You have a specific data frame. This is in case of tabular data sets. You have a specific data frame. You have a variable that you want to predict, which is the response variable y, and various other x variables that you can use to predict the y, isn't it? We want to understand the relationship between the x and the y. Basically, we want to understand which of the x variables, the predictors we have in the data, is actually useful. All right. Sometimes, in addition to the relationship between the x's and the y, we also want to understand the relationship between the various x variables also. That is also helpful to come up with new x variables, new engineered features for your analysis, for your model building. All right. So that is another purpose. The third purpose is to generate insights that gives more understanding and the business context and performance. This is a very important step. This is the key step where you will generate value for your clients, whoever you're doing the data science project for. So when you start your data science project, it can be quite a while before your clients start seeing the results that come to a stage where you have generated the model and your clients start getting the usefulness of your machine learning models. Now, practically, if you start working in corporate companies or even with clients, you want to generate value from the beginning of the project itself. You want to demonstrate that you can generate value, right? So doing this EDA step, you will be able to generate a lot of insights. You have to generate the insights in such a way that it reveals and explains to your clients. They will get to know more about the data that they have, whatever the problem that is they're dealing with. So what do I mean by that? For example, let me scroll a bit. So in churn modeling problem, we are dealing with a churn modeling problem where the objective is to predict if a given customer has churned, that is exited from the business or not. So that is the churn modeling problem. We will be solving this problem. This is part of a larger series, isn't it? Now, in this problem, it would be interesting to know if a particular age group is more prone to exit, more prone to churn. Right? This is the data set that we are dealing with. There are various customers here, and there is a specific column towards the end which we are trying to predict. That is nothing but the exited column. So we have the customers. We want to know which amongst these customers are more prone to exit. So with this objective, it would be very interesting to know if a particular age group is more prone to exit. Does a higher credit score means lower exit rates? Do younger people have higher credit scores? Various different kind of insights you can generate from any given machine learning data set. That is data sets that are meant for building machine learning models. Okay, so let's get to the hands-on. First, we are importing the data. First, we are importing the data using pandas. We are importing pandas first, then use pandas.readcsv. This data set is available to you. You can download this, and we are loading it into, we are storing it into DF, and this is how it looks like. After this, this is an optional step where I am defining what's the input file name, what's the target class, what's drop columns that we want to drop, various kind of things. This is optional. Just I'm storing it here for later use. My way of standardizing stuff. Not very important right now. All right. So very first example that we want to see. All right. So let's get started with the EDA process itself. Very first step that we will want to see is, especially in case of data sets that contains categorical data. In this particular data set, the y variable is whether a given customer has churned or not. Right? This contains two values. Whether a person has exited. When it is exited means it is 0, and if it is not exited means it's 1, and if it's not exited means it's 0. Right? Now we want to get the frequency counts especially for the target variable churned, or in this case it's called as exited column. For this column, what is the number of people who have actually exited? All right, you can do this for the target variable. You can also do this for the other X variables that might be categorical in nature, categorical X variables. So that is additionally you can do. Here we are doing only for the target class. Now you can see here the distribution of people who have left the churned people is quite significant, and it is not balanced. The number of people who have churned and not churned is not equal. It's not in the same proportion. So that indicates a significant amount of class imbalance. It's not very extreme, but you need to understand it's not in a 50-50 ratio. All right. It would be considered more extreme if we have less than 100 or less than 50 number of people who have actually churned from all of the entire data set. All right. So this is okay. We have a better understanding now what's the percentage of churned people. Good to do this for other X variables also if there exist. All right. So next step is to see the distribution of every other feature that you have in the data set. So we are going from very simple, slightly more involved one. So to plot the distribution, I'm simply using the df.hist function, set the figure size, you can adjust this, and setting the number of bins to 50. This is also arbitrary. You can try out 10, you can try out 20, various different numbers, whichever is giving you a fair shape, depending on the size of the data also. You might want to try out various values. You can start with 15. All right, this works well for me. Now, here, what you want to observe here? You want to observe the general shapes of the distribution.
Now, one thing you need to understand here is if a variable is completely random, it tends to have a flat head in this distribution. For example, both row number as well as customer ID, they don't contribute any type of information to the data. Both of them are just IDs. Now, because of that, each of the numbers in the x-axis, both row number as well as customer ID, has an equal probability of occurring because they occur only once in the data. So they don't contribute any type of information to it. So in that instance, it follows a flat head, and that is what we normally refer to as a uniform distribution. Whereas variables such as credit score, age, these kind of variables tend to have a bell-shaped curve. We normally refer to as a normal distribution. We're not calling it as a normal distribution yet, but it is following a bell-shaped curve, and you can generally observe the shape of the distribution. You can observe that the maximum frequency value occurs somewhere over here. Likewise, for age variable, the maximum frequency occurs somewhere over here, around less than 40 years of age. So generally observe the shapes of the distribution and the number of peaks that occur. For instance, there could be some variables, it doesn't exist here, but there could be some variables where you have a variable that looks, a shape that looks something like this. This involves two peaks. What could internally it mean is, it could be composed of two different distributions. One distribution that is having a shape like this, and another distribution that is having a shape like this. Both of them getting mixed together will form one single uniform or rather two-peak distribution, which might occur like this. So these are some things you want to observe. Such two peaks and three peaks, if they occur, it could mean that there could be two different segments of customers, or if there were three peaks, it could mean there are three different segments of customers. If such things occur, if you observe multiple segments of customer, you have an option to build different machine learning models for each of the segments. For example, let's say this color, let me put it in a different shade of green. So let's say this is another segment of customers, right? You might consider building a separate machine learning model for this set, and one model for the yellow set, and one separate machine learning model for the light green set. We don't have to think that far ahead right now. This is just an option you have. Likewise, for tenure variable, the values itself ranges between 0 and 10, and you can clearly see these are integer, or rather you can treat it as an integer variable. You can also treat it as a categorical variable. In this case, you can clearly see some segments occurring over here. Likewise, for balance, you can clearly see a bell-shaped curve, and there seems to be a good number of people who have zero balance also. All right, this is a segment that is having a good number of people who have a zero balance in their account. Okay, then number of products, we see three distinct segments, and hash card also 2 different segments. This is definitely categorical. Then you have is active member, then estimated salary. This is also seeming to be a uniform distribution. There is not much of a pattern, but it's not completely uniform. Certain values seem to appear to have a slightly larger probability of occurring here. All right, and then finally we have the exited column. So this gives us more understanding about the distribution of the underlying feature variables. All right, now let's get into slightly bit more detail about this. Now we want to check how the different numerical features are related to the target class. To be more specific, we want to know which of the numeric features we have. We have age, we have the balance, we have credit score, various numeric features exist. Amongst them, which of them are more useful to predict the target class is exactly what we want to know. How do we determine that? Say, given, let's take out of the entire data set, let's take 2 features alone. That is one x variable and one y variable. The y variable here is the exited column, and x variable let's call the age, let's say. All right. Now we want to know if, say, exited column here has 1, 0, 1, 1, 0, 1, 0, and so on and so forth, and various values of age also exist here. Let's say this is our data set. Now we want to know if the age here is a useful variable in predicting exit. How do we, logically speaking, how do you determine that? How would you understand that numerically? Now, a very common, very sensible thing to do here is to sort of split the data. Take all the observations where you have 1. So we have 1 here, 1 here, 1 here, 1 here. Take all the ones here, one in the data. Take all those rows and compute so for ones and for zeros separately, compute the mean of age. And we observe, let's say, all the people who have exited has an average mean age of 50 years. Let's say, we haven't computed it, average mean age of 50 years. And all the people who have not exited have an average mean age of, say, 35 years. Right? That's a significant gap between the age of the people between 0 and 1. Right? This indicates, okay, younger people are tending more towards not exiting, and more older people are tending towards exiting. That's what it would mean, isn't it? If that is the case, then age is probably a useful feature to predict the target class in this case, isn't it? That's the general intuition behind how you can determine if a given numerical feature is a useful feature or not. Now here, in this approach, computing the mean itself is sort of highly aggregate. We are aggregating the entire data. So entire column, we are aggregating it to one single number. By doing that, we are losing a lot of variations that exist in this data, isn't it? So if this is happening, this is for sure, this is an important variable. But we might lose out on variables that could still be important. So in that case, it would be helpful to study the overall distribution itself, and that we can do using the box plot. Now, how would that look like? Let's look at it. If you scroll down, this is the code to generate the box plot. Here I'm setting the number of columns, number of rows, then using plt.subplots. PLT is the matplotlib pyplot function. We are calling subplots to create the number of charts here, and then iteratively we are using sns.boxplot function, and passing in what goes in the x-axis, what goes in the y-axis, and ax is the axis that we have created in the plt.subplots function. All right, this is not very important. Just understand. You will get access to this notebook. You can see this and try it out further later on. But the intuition here to see this, to understand this, is as follows. Say you have. Let me scroll up a bit. Okay. So say you have these box plots, right? You have the credit score here. you have the age, you have the tenure, all right, and the x-axis you have the box plot on the green refer to all the non-churned, the zero customers, non-churned customers, exited value is 0, and the orange here refers to the churned customers, the value, exited value is 1. Now, if a variable is a useful variable in predicting churn, suppose if we want to know if credit score can be helpful in predicting churn, then in such case, the chances are we will observe that either the position of the boxes, or the length or the shape of the boxes, the length of this box here, right? Either the box or the end of the whiskers also. Something should be different about the entire chart, or the position of the box, or the median line also of the box, or the median line, which is nothing but the center line we have over here. We can see that it is not exactly on the same vertical axis, vertical length, right? This line, this median is slightly, I'm not sure if it is visible here, slightly lower than the left hand side median line. Likewise, let me clear this. Likewise, the lower end of the box is also slightly lower than the previous blue line. This does matter, all right? This small differences does matter, and this could be helpful, in turn be helpful to get to know that helpful as a predictor variable to tell if this exited column can be explained using credit score or not, all right? With the credit score column, this differences is very slightly noticeable, all right? But with the age column, it's very clear. With age, people who have attrited or who have churned seem to have a significantly larger age. Here, I think it's coming somewhere around 45. And people who have not exited, slightly above 35, I think 36 years of age. So age is definitely a very useful variable. So we understand credit score is useful, age is also useful, definitely tenure is also useful. Clearly the median is occurring at the same level, but the shape of the box is clearly different. All right, tenure could also be very useful. Then we have balance. Yes, definitely the medians are different lengths. Medians are in different positions. I can't say so clearly for sure about the number of products. We cannot say, but in both of these boxes, the positioning, everything is the same about both of these boxes. But we do not say that this variable is not useful. We do not conclude that this variable is not useful. We can only say if a variable can be useful or not. Why? Because there could be some pattern. This is not the entire data. This is again a summarization of the data, right? There could be some pattern that exists within the number of products variable inside the data that could still be useful in predicting the exited column or not. That is not visible here in the box plot. All right. So we do not never conclude visually that this variable is not a useful variable. All right. We only take notes of where it is useful. Here, estimated salary there is a slight difference here, so this is probably a useful variable also. That's how we use box plots in exploratory data analysis, and based on this we will make our inferences, and these in turn can be used as your when you make your PowerPoint deck or when you make your Jupyter notebook, whatever way that you are presenting your results to your clients, in that deck or dashboard, whichever one you are creating, in that you can definitely point these observations out. All right. Next one, you can do the same thing by comparing distributions amongst the features. Here we are using something called as the joy plot. This is not very common. This is a super good trick, which is nothing but density plots that is plotted for the different values of the y variable. All right. So here the y variable has 0 and 1, and just like the way we did for box plot, we can do the same thing for using the density plots. Here we have the age by the exited column. So here one value of, I think this is not churned, and this is churned. So this is the age. The first one is the age. You can clearly see. Okay. By the way, this code you can create this joy plots using this library called joypy. I'm creating what all variables we want to create this, and you need to do a pip install joypy if you haven't done so for the first time, because this is not a default regularly used library. It's not, unlike matplotlib or seaborn, this is not that common. All right. So but this is very useful for this kind of a visualization. Use joypy.joyplot, pass in what's the data frame, what's the variable that you want to plot it for, by variable is exited, all right. Mention all of these things, it will simply create these plots, very straightforward, all right. So once you create this, you can observe clearly. Likewise, tenure also, you can clearly see a difference between how these two variables are. This tenure is distributed between exited and non-exited. Clearly, these kind of peaks don't occur. These kind of peaks don't occur in the bottom part, and I think the ending part, the shape of the distribution is also slightly different. Likewise, credit score, there is a difference. Yeah. Likewise, balance by exited, the height of the peaks certainly tends to change. This is more peaked, whereas this is less peaked. Right? This will not be that easily visible in a box plot. So this gives more information to us. Yes. Likewise, estimated salary also, there seems to be slight differences in the way it is distributed. Now, if you want to mathematically confirm, that is statistically confirm if a given variable is useful or not, right? We are not going to eliminate a variable again here also. We are not saying this to not include a variable in a given model. That's a different part of feature selection. We are not doing that here, but to confirm statistically if a given variable is useful or not, you can use ANOVA. ANOVA simply the importance or the mathematics behind how ANOVA works is not important right now. We will reserve a separate video for getting into the details of how ANOVA works. But right now, understand ANOVA is a statistical significance test that can be used to predict if there is a significant relationship between a numeric variable and a categorical variable. Right? The categorical variable in this case is exited column. The numerical variable can be something like the age, the balance or the salary or anything else. All right. So we can use ANOVA. Simply, we are importing the OLS function from statsmodels.formula.api. We are importing OLS. To this, pass in the numeric column as a function of the categorical column. So this in our data, the exited column is our y variable. All right. But when you pass it to ANOVA function, the OLS function, you need to pass the numeric column here. This first observation here should be the numeric column, and the categorical variable should come on the right hand side of this equation. So define your OLS. OLS stands for ordinary least square. This is the function that is used to build linear regression using stats models. But the way we need to run ANOVA is to first build this linear regression first. We're basically building a linear regression model and then passing that linear regression model to ANOVA.lm, right? That will build the ANOVA. The only thing that you need to notice here is the p-value. After you build your ANOVA model, observe the p-value. If it is lesser than 0.05, typically we keep the alpha as 0.05. If the p-value is lesser than alpha, we reject the null hypothesis. We don't have to go into the technical details. Like if you don't understand what the null hypothesis is prior to this, don't worry about it. It's not very important. Just simply understand right now. If the p-value is lesser than 0.05, then we reject the null hypothesis that there is no relationship between the x and the y. Typically, that is how the null hypothesis is defined. Right? There is no relationship between the x and the y, and we conclude that there is in fact a significant relationship between the two numeric and the categorical variable we have defined in this formula. All right. So here clearly p-value is lesser than 0.05. So age and exited are definitely having a significant relationship. So far we have seen first we saw the frequency counts. Second, we saw how the variables are distributed. Using the histograms. Then we saw the box plots. Now, for both the first two cases, both of them are considered as univariate analysis because we are looking one variable at a time. Frequency counts, we saw one variable at a time. Likewise, distributions using histogram, we also saw one variable at a time. But next we saw box plot, and then we saw the joy plots. When we see this, we also saw the ANOVA, how to use ANOVA to see if there is a relationship between a numeric and a categorical variable. These three approaches These two, basically box plot and joy plots, both of these approaches, we normally call it as bivariate analysis. Since this involves a significance test, the ANOVA test that we did involves p-value, and whenever you are seeing a p-value, it means that there is some sort of an hypothesis test involved, and that makes it a statistical test. Statistical test. All right. So this is what we have seen. Finally, one more technique that we will see in bivariate analysis is using what is called as the scatter matrix, or scatter plot, that is made up of all the possible x and the y variables that you have in the data. An interesting feature of the scatter matrix is it could be useful to expose the interaction effects that could exist in the data. What do we mean by interaction effects? Say you have a variable, you have the data set, you have the various x variables and you have the y variables here in the data set. Bivariate analysis involves understanding the relationship between each of the x variables and the y variable. Right? That's what bivariate analysis is. Now, it could be possible that a combination of some of these x variables, when combined together in various forms, a combination of those x variables can in turn be more useful as a predictor instead of just one single x variable on its own, right? So combining one or more x variables together, it could be an addition, it could be a multiplication, it could be a multiplication and then squaring it could be various forms. By having such interaction, we are able to increase the predictive power of the data. Now typically scatter plot is something that you would create when both the x and the y variables are numeric variables. But here we have the y variable as a categorical variable, in which case this scatter plot matrix in turn can help reveal all these interaction effects. Let's see how that can be done. Now let's create a pair plot. You can create the pair plot using the sns.pairplot function. First we are setting the font scale here, sns.set. This will globally set the scale of the font. Alright, setting to 1, it doesn't matter, you can adjust this later on. Then we create the pair plot. This is how it looks like. I've reduced the font size so that you can see more of this chart. Now here what we have here is all the variables. We don't have the y variable as one of the boxes. The y variable in fact colors the points we have in the data. So we have the x variables, the numeric x variables, which is credit score, tenure, age and balance, the 4 main numeric x variables, and we are creating a scatter plot for this, simply drawing all the points against each of the individual variables. For example, this plot here is the plot between credit score on the y-axis and I think age on the x-axis. For that I have to come down here. Okay, this is tenure on the x-axis. So this is tenure on the x-axis and credit score on the y-axis. Now here, how to identify the interaction effects? Whenever there is a clustering of the data points, right? Whenever there is clustering appearing here, for example, here you can see that all the churn customers, the orange ones are the churn. These are the customers who have churned. These customers tend to populate in this region. So what this clustering means is, for certain ranges of values of both the y and the x variables, the customers seem to have churned. It's not completely scattered and completely distributed all over the place. You can see that the churned customers exist for certain ranges of values of both the x and the y variables based on this particular scatter plot. Isn't it? If there is no relationship between the credit score and I think this is the age, if both of these variables are completely random, they don't have any relationship between them as well as the data points, as well as the exited data, isn't it? If there was no relationship existing, then all these points will be completely scattered out like the night sky. So we observe some amount of clustering happening here. Here also there seems to be some amount of pattern that exists. It's not completely random, right? This chart here, this I'm not so sure. We cannot be so sure here whether it's clustered or it is random. So such kind of interaction effects you want to take note of and maybe create a new variable based on that. For example, clearly credit score and age are related, right? You might consider creating a new variable that is a product of both credit score multiplied by age. It could be a multiplication or it could be normalized with age. You can simply divide this credit score with age. This could also be a variable that you might want to consider building and having it as a separate variable in your model. So this is one observation. Another observation is looking at the density curves of each of these plots. This is what we observed using the joy plot also. Using joy plot, we observed exactly this. How is credit score distributed? The density curve of this is the density curve, right? So how is the density curve looking like for credit score for the two different values of exited? When exited equal to 1, this seems to be distributed like this. When exited equal to 0, it tends to be distributed more, having a more peaked curve, all right? And more difference between these two distributions, these two curves, the higher the chance that that particular variable is useful. Clearly, credit score is useful, tenure is also useful, age is also definitely useful. Likewise, we can see the next one. Here also, balance also is useful. Okay, that's how we make the inferences. Finally, we have another option called pair plots using the reg option. In the pair plot function, we set reg for the pair plot function. We set kind equal to reg, and this will give you this kind of a plot. This will make more sense if both the x and the y variables are numeric. But here we can observe this pattern only for the different x variables. So, for example, the y-axis here is credit score, and the x-axis is tenure. If these two variables are interacting, like together, if these two variables forms a more useful variable, useful feature, if that could happen, then we have here the lines of best fit for, I think the blue line is the not attrited and the orange line is the attrited. We have two different lines, two different lines of best fit. These two lines will be having a different slope. Basically, if they are having two different slopes, then the chances are the interaction variable of credit score and tenure, that is the product of credit score and tenure, is a more useful variable in predicting if a given customer churned or not, right? This effect is observed more for this particular combination, that is credit score and age, right? For this, we can see that these two slopes are slightly different. Visibly, they are having two different lines. But again, since they are very close to each other, we cannot be 100% sure that this variable is for sure a useful variable or could be a useful variable, but this could be worth a try. So those are 5 different techniques you could use to perform exploratory data analysis. But on a high level, understand the purpose of EDA is first to summarize the data, again revisiting the original points. First, to summarize the data. Second, to understand the relationships between the x and the y, also between the x and the other x variables. Third, to generate insights that could be useful for your client, and it should be an eye opener. Typically, it should be a worthy eye opener for your insights that your clients were not aware of prior to giving the data to you. Or it could also be a case where you are scientifically confirming the beliefs that they once had. For example, credit score influencing the churn rate, the churning of their customers. They might have a belief around this, but you are confirming this using data. These kind of insights are also deliverables that should come out of your exploratory data analysis process.